This is our third lesson in our unit on polygons, and today we're going to learn several more theorems that will help us to prove whether or not quadrilaterals are parallelograms. So here we go. Let's start looking at these theorems. The first one says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Second theorem says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Third one says, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Next, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And finally, if one pair of opposite sides of a quadrilateral is both parallel and congruent, it's got to be the same set of sides, then the quadrilateral is a parallelogram. All right, so I'm sure we got some examples coming along so we can see how this plays out. If I can get my page to turn. Here we go. Oh, we're going to start right off with a proof. Okay, so we're going to prove one of these theorems. We're going to prove the theorem that says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So let's draw our parallelogram over here. And what do we got? JKLM. JKLM. Okay, so how are we going to prove that a quadrilateral is a parallelogram? Well, we know certain things. We've learned a lot of theorems, and today we've learned some more. If the diagonals bisect each other, if you know, all those ones we just talked about. But this one we're using now, that we want to prove, we can't use it in our proof, so we may even have to go back to, let's say, the definition of a parallelogram, which I hope you remember is a quadrilateral with opposite sides parallel. So let's put down our statements, down our reasons. Number one, we're going to write the given statement. Angle J is supplementary to angle K and angle M. That's given. Okay, so let's say we call angle J X, then I know that, or X degrees, so if angle J is supplementary to K, then I know K is 180 minus X degrees, and so is M, 180 minus X degrees. All right, so let's see if we can draw any conclusions based on that. Oh, look at this. If these two angles here, J and K, are supplementary, then what does that tell me? Doesn't that tell me that KL and JM are parallel? I believe so. So let's document that here. KL is parallel to JM. And I could also do the same with the other two angles, right? Angles J and M. If I know that J and M, angles J and M are supplementary, then I also know that KJ is parallel to LM. So I'm going to write that down too. KJ is parallel to LM. And how is it I know that? It's something I learned a long time ago. I know what kind of angles are those? They're corresponding angles, right? And it's the corresponding angles converse that tells me that those lines are parallel. So the corresponding angles converse tells me that both of those sets of opposite sides are parallel. And since I know that the opposite sides are parallel, I know that JKLM is a parallelogram. That was an easy proof. And how do I know that? Because that's the definition of a parallelogram. Alrighty. So we could prove the other theorems in a similar manner, but we're just going to stick with that one there. Okay, here's an example. A pane in a stained glass window has the shape shown below. How do you know the plane is a parallelogram? Well, I can see the opposite sides are congruent, right? Both pairs of opposite sides are congruent. That's one of the theorems I just learned today. So how do I know? I'm going to say the theorem that says both, and you can paraphrase the theorem, both pairs of opposite sides are congruent. That's how I know it's a parallelogram, because there's a theorem that tells me so. Okay, what else we got here? Oh, can you prove the quadrilaterals below are parallelograms based on the given information? Well, let's see. We're given that AB is 5 and CD is 5, and we've got those angle measures there, so we want to know, is ABCD a parallelogram? Well, the two angles that were given, A and D, they're definitely supplementary, right? They're supplementary, so I have to think, what does that tell me? Oh, it tells me that AB is parallel to CD, right? Isn't that what that tells me? Because of the corresponding angles converse again? So yes, and I'm not doing a full proof because it just says, can you prove? And I'm just going to say, yes, I can. Yes, ABCD is a parallelogram because there's a theorem that says if one pair of opposite sides is both parallel and congruent, then I know the quadrilateral is a parallelogram. Because of the theorem that says a pair of opposite sides is both parallel and congruent. That's how I know. I can prove it. I could write a 2-column proof if I wanted to do that. Okay, how about in B here? We've got HI is congruent to HK, all right, and JI congruent to JK. Is HIJK a parallelogram? Well, it could be, but there's not enough information here to know. What's wrong? What's wrong is that I need the opposite sides, both sets of opposite sides to be congruent, and I don't know that's the case here. So I'm going to say not enough info to prove. Not enough info, because I don't know anything about the angles, so I can't tell whether any of those sides are parallel or not, so there's just not enough information there. Okay, how about number 2, EF. So EF is congruent to GD, and DE, it's already marked, DE is parallel to FG. Is this a parallelogram? Well, what do I have to know? I have to know that one pair of opposite sides is both parallel and congruent, and that's not what I know here. I know that one pair of sides is congruent, one pair of sides is parallel, so once again, not enough info to prove. Not enough info. Okay, how about B? Angle ALN, so this one right here, is congruent to wait a minute, ALN is congruent to DNL, sorry, right there. Angle ANL, this one right here, is congruent to DLN, which is this one right here. So is this enough to prove that LAND is a parallelogram? Well, let's see. Looks like I got some alternate interior angles, right? So because of the red angles I have marked, I can say AL is parallel to DN. And because of the green angles I have marked, I could say AN is parallel to DL. And therefore, yes, I can prove that land as a parallelogram? By the definition of parallelogram. Opposite sides are parallel. There we go. All right, what's next? More problems, more problems. Maybe I'll do some and then I'll stop and let you do some. That's what we like to do. For what values of the variables must A, B, C, D be a parallelogram? Okay, well, let's look at angles A and B. What do we know about angles A and B? We know they're supplementary, right? Because they're consecutive angles. So I know that 3x plus 10 plus 8x plus 5 has to be 180 because those angles have to be supplementary. So let's see what I got here. 11x equals 180 minus 15. 11x equals 165. So x is going to be 15. X is 15. Okay, so let's just go ahead and plug that in and figure out what the measure of angle A is. The measure of angle A is 3 times 15, which is 45, plus 10, which is 55. 55 degrees, and I know that that has to be supplementary to angle D, right? So the measure of angle A plus the measure of angle D equals 180. So I'll pick a different color for that. So measure of angle A plus the measure of angle D has to be 180 because they have to be supplementary. So 55 plus 5y equals 180. So 5y is 180 minus 55, which is 125. So that means y has to be 25, if my math is okay. All right, so those are the values x and y have to be for that ABCD to be a parallelogram. All right, let's see what we have next. 2 more problems. I think this would be a really great time for you to pause and do these next 2 problems. Come back and I'll have the solutions for you to check your work. Okay, here's how I went about our second problem here. I looked at my opposite sides, AB and CD. I know they have to be congruent because the theorem tells me that if I got a parallelogram, opposite sides are congruent. So I set those 2 side lengths equal. 2y plus 2 is 3y minus 9. Solve a simple algebraic equation and I get y equals 11. So then I plug 11 in right here for y and I find out this side length is 15. So therefore, I know this side, that's 15, has to be congruent to the other, its opposite side. So I set 3x plus 6 equal to 15 right here. Solve that for x, and I get x equals 3. In the next problem, what do I know? Well, I know that all the consecutive angles, I know that D is a right angle. So I know its measure is 90 degrees. Therefore, I know that angle BCD also has to be 90 degrees. And I know that angle BAD also has to be 90 degrees. So I kind of went about this in a roundabout way. Now that I'm looking at my work, I'm seeing there was a much easier way to do this. Both of the angles that are labeled there in red, they're alternate interior angles, right? And they're made by parallel lines. So I could have simply just said 2x plus 15 equals 4x minus 33. And then I would have, let's see, 33 plus 15, 48 equals 6. Wait a minute. Something's wrong here. Let me study this for a moment. All right, I'm starting all over on this one. I looked at this problem for quite a while. Here's what we got to do. All right, we know that AB is parallel to DC, if this is a parallelogram. So therefore, I know that the 2 angles that are marked in red are congruent to one another because they're alternate interior angles. So all I really need to do is set those 2 equal to each other. 2x plus 15 equals 4x minus 33. So 15 plus 33 is 48. 4x minus 2x is 2x. And that tells me that x is 24. Much simpler than I had done it the first time. Okay, and finally a proof. Let's see what we got here. Triangle TRS is congruent to triangle RTW. Okay, so the two triangles we see there. So I'm going to go ahead based on my congruent statement of the triangles, and I'm going to mark my corresponding parts in these two triangles. So I know that RS is congruent to TW. RS is congruent to TW. And, well, I'll keep blue. I know that ST is congruent to WR. So doesn't that tell me? Isn't that it right there? There's a theorem that says if opposite sides of a quadrilateral are congruent, then it's a parallelogram. The quadrilateral is a parallelogram. So let me just get that into a proof here. I think it's a pretty short, straightforward one. Statements. Reasons. Triangle TRS is congruent to triangle RTW. How do I know that? They told me. All right. So now I mark this. I know that RS is congruent to TW. And I also know that ST, and remember order does matter here when you're writing these congruent sides, ST is congruent to WR. And how do I know that? Because those are corresponding parts of congruent triangles, and I know that those kind of parts are congruent. So there I have it. RSTW is a parallelogram. And how do I know that? By the theorem that says both pairs of opposite sides are congruent. And there you have it. So guys, I've been noticing that some of you are not writing your summaries, you're not really writing essential questions, and I have not been very hard on you. Some of you are doing it, and you're doing it beautifully, diligently. But there are so many theorems in this unit that if you want to forego writing your summaries, then please, please make your flashcards and know what these theorems say. All right, we'll see you next time.